So firstly, to explain the title of my talk, what I want to cover today is changes that are happening in the stub to recursive world. So very specifically, what's been happening recently in how end devices are changing the way that they do DNS, what's been happening in the last 5 or so years, and what's coming up in the next 1 to 2 years. So what I'll cover today is some of the new standards that have come out of the IETF in terms of encrypting DNS traffic, stub to recursive. So that's doing it over TLS and over HTTPS. I'll talk about the deployment status of both clients and resolver services for those protocols. And I'll also talk about some of the more recent changes with moves for applications to do DNS resolution from directly within them and to send those queries to cloud-based services. A little bit of background about me, why I'm here, why I'm talking about this. I'm co-founder of Sinodun IT. We're a small Oxford-based consultancy. We do all things DNS. We focus on R&D and also open source software and open standards development. So for full disclosure, we were quite tightly involved in the development of DNS-over-TLS, in drafting some of the specifications, doing some of the very early implementation and deployment. And we also contribute to a collaborative effort called DNSprivacy.org. We run a website where we try to be a single point of information for everything that's changing in this arena. We were not directly involved in any of the development of DNS-over-HTTPS. That really came out the browser side of things, and we have no direct links for browser vendors. We don't consult for them, so I'm as much of a spectator as you are to many of the developments that are happening there. So what I really want to do today is just bring to this audience an awareness of what's changing and how fast it's changing, and that's the good, the bad, and the ugly of thinking about encrypting DNS. So I'll start by saying DNS is really showing its age. It's over 30 years old, and neither security nor privacy were built in at the beginning, so we're having to retrofit this into the protocol. The interest in adding privacy into DNS started really about 5 years ago with the Sinodun revelations. The IETF took a very strong view on this, and they published a document declaring that pervasive monitoring is an attack on the internet and the users of the internet. And they then said that from that point forward, they wanted all protocol development to mitigate pervasive monitoring as part of the protocol design. Specifically in terms of DNS, they spun up a brand new working group called Deprive DNS Privacy. And its initial goal was just to consider encrypting stub to recursive, which is what it worked on for several years. It's now considering a rechart. It's just recently been recharted to also look at the possibility of encrypting recursive to authoritative, but that works in a really early stage, so I'll focus on stub to recursive here. So they considered lots of different technologies, but what they finally settled on was TLS as the right protocol to use to do the encryption. First of all, we actually had to go back and realise that DNS over TCP had never been specified properly, so it could be almost as performant as UDP. So we actually went back and re-specified how DNS works over TCP, and then we got a new port assigned by IANA, port 853, so that we could run dedicated DNS over TLS on that port. So where are we with DNS over TLS, or DoH as it tends to be called? We have a number of implementations. The most recent release of Android Pie, now does DNS over TLS opportunistically. It will probe the resolver it gets from DHCP on port 853, and if it finds it gets service there, it will use it. Love it or loathe it, System D is going in exactly the same direction in terms of doing opportunistic DoH. And there's also Stubby, which is a desktop client, which you can install and use to proxy all your DNS queries out over DNS, over TLS to configured servers. DoH has also been implemented in most of the major open source DNS resolvers. Bind is in the process of adding it, but it's already in Unbound, Not Resolver, and DNS Dist. Over the last few years, we have seen a number of individuals and organisations stand up test servers to do DoH. And back in 2017, you might be aware that Quad9 actually started a brand new service, and they included DoH as an offering on that. And shortly after that, CloudFlare also included DoH in their Quad1 service. So you'll notice here that most of the implementations I've mentioned are system resolvers that are just adding DoH in. We are still missing Windows and we are still missing macOS, but I'm hopeful they'll be implemented in the not too distant future. But I also want to say that if you want to stand up a dot server today and you're using any of this software, it's really relatively straightforward. It's just a config change. So to spin back a little bit and think about what you actually get, what the differences are when you encrypt DNS traffic. So firstly, it ticks the original box, which is defeat passive surveillance. And one thing I want to draw out here is that you can do this by probing the server you get from DHCP. You only need an IP address if all you want to do is encrypt the traffic without authenticating the far end. And this is a mode called opportunistic DOT. And this is exactly what Android Pie does. There's a separate mode, which is called strict. And in this case, you actually need to manually configure an authentication name into the client. At least you do today because there's no mechanism to get this over DHCP. But once you also have a name in your client, it means the client can authenticate the far end using a certificate or, hey, even Dane, this is DNS. And the nice thing here is that, of course, it means that your client cannot be redirected to a rogue server because it can choose to hard fail if it can't authenticate the far end against this name. And it also means that intercepting DNS queries goes into a different category if clients are doing this kind of authentication. One other thing it does is it can increase trust in the server at the far end. If you have chosen to configure a server because you know it does a certain service, that could be DNSSEC validation, it could be some form of filtering, then when you're doing strict DOT, you are guaranteed to be getting service from that resolver that you think you are. And as a nice side effect, you also get data integrity in the transport, which means that if the traffic's in an encrypted stream, you cannot inject spoofed responses. Okay. So while that's all shiny and awesome, it doesn't solve every single problem. SNI still leaks. There's often a pushback saying, why are you even bothering trying to encrypt the DNS when SNI leaks? Well, it does today, but hopefully not for long. There is a new draft in the IETF proposing how to do this in TLS 1.3, and there is proof of concept code to do this as well. So it looks like in the very near future, SNI will not be leaking in TLS 1.3. One downside of using a dedicated port for this is obviously that port may be purposely or accidentally blocked. So that can stop you getting service. But there is the possibility that if the server offers it on port 443, you can just shift dot traffic to 443 to circumvent this. But the interesting thing here is that once you're stopping surveillance of the network traffic directly, the thing that becomes the focus here is that the resolver can still see all the traffic. So the fact the resolver sees the traffic means that, in a sense, that now becomes the biggest attack vector here. It's all about who you're sending these encrypted queries to. Who do you trust, and who do you trust to see your users' queries? So at the moment, there aren't that many dot servers being run, although we are seeing it being done increasingly. Most of them are test servers or cloud-based. So privacy-conscious users who want to do this today, they are often using resolver that's not on the network. Now, there are disadvantages to this because it can break a whole number of things depending on how your network is set up. One of the obvious ones is that it will break split horizon DNS, and it will also leak internal names out to that third-party DNS provider. Now, this already happens in some circumstances today if people choose to, say, configure Quad 8 or Quad 9 or Quad 1 on a device. But at least today you can see that traffic. What changes is that if that traffic is encrypted, it can bypass all your local monitoring and your security policies. Now, I think it's fair to say that where DOT has gone in terms of implementation and deployment is that the expectation is it would be implemented in system-wide resolvers, and the goal was that everybody enabled DOT. So this sort of bypassing of local networks would be rare, and it would happen in the short term as deployment ramped up, and in the long term, it would be just the odd user that actually configured to go around this. So that's the story with DOT. The heads up I want to give you here today is that that's not necessarily where implementation deployment of doing DNS over HTTPS is going. What we're seeing here is the browsers are pushing doing DoH, as it's called, DNS-over-HTTPS, out directly to cloud providers. So firstly, to go back to where the DoH standard came from, the first time I heard it talked about really seriously was about 18 months ago at one of the IETF meetings, and a draft was published quite quickly. One thing to point out about how this draft specifies DoH is that this is talking about doing query initiation directly within HTTP streams. So it's embedding wire format within gets and posts. There have been previous proposals just to tunnel DNS over HTTP, but that is not this. They formed a DoH working group, and the working group remit was actually quite narrow. It was just to specify how to encode it. But what we're seeing in the wild is use cases which go far beyond this charter and the way this was specified. So the draft was adopted very rapidly, and after less than a year of review, it was submitted, and it is now about to be an RFC. So this is happening. And in the snail's pace world of the IETF, this is pretty darn zippy to get from a proposal to an RFC. I want to call out a couple of specific differences in actually the protocol level specification between DOT and DoH. The first one is to be aware that in the DoH draft, it explicitly calls out the use case of it being directed towards web applications accessing DNS information directly through APIs. So it had a very different goal from the get-go. The second is in terms of the discovery. Strictly according to the spec, you need to use a URI template to access a DoH server. And today, there is no discovery mechanism that can get you that template, and you can't bootstrap it from an IP address. So effectively, at the moment, there is no equivalent of an opportunistic mode. You have to have manual configuration in the client. Now, there's work on discovery, but there's nothing there yet. Where things really start to get interesting is when you think about the connectivity model. So one way you do DoH is that an application would open up a single HTTP connection, and it would send nothing but DoH requests over that connection. And that's interesting because it will look like HTTP traffic in terms of the initial connection, but you might be able to spot that it's DNS from the traffic pattern. So it's still relatively hard to block. The second model is that, hang on, I might already have an HTTP connection open to something that I know handles DoH at the far end. And in that case, I can just send DoH requests over an existing stream and mix it in with my traffic. Now, there's some arguments that from a privacy perspective, this is good, because say you've got a tab open on your browser to your bank, you can send all your DNS queries down that connection, and you're not leaking anything to a third-party DNS operator, because the bank already knows all the content you're going to request. It gets interesting, though, when you think about the fact that if that's what's going on, it becomes impossible to block just DNS traffic. As an operator, you won't even necessarily be aware that resolution is happening on that connection. So this opens up a whole range of possibilities. One other thing I want to call out is that today, if you have a resolver operator and you're connecting with your device, if all your queries are going over the system resolver, then there's one stream of queries from the whole device going up to a resolver service. With DoH, if you have different applications doing it, each one will probably open up its own HTTP stream, and inside that stream, it will pepper the DoH requests with multiple HTTP headers, for example, user agent, languages, etc., which means that if all those queries go to one resolver operator, they then have the opportunity to profile user behavior down to the application level, and that suddenly gives a potentially malicious operator a whole different picture of what's happening on the end device and what is triggering individual DNS queries. So there's a whole range of privacy concerns that spin up here because you're using HTTP. So where is DoH? Well, I would say that probably in 18 months, it's got to an almost equivalent stage as DOT did in about 5 years. And that's really because the browser vendors are behind it. In terms of deployments, CloudFlare stood up a DoH server at the same time as their DOT server. They offered both services in parallel. So they're really the big player in terms of resolution service at the moment. Google do have a service, but they've taken pains to say that it's experimental and it's only for small-scale traffic. And there are numerous other test servers, and they seem to be popping up every week at the moment. In terms of implementation, Firefox, and particularly experiments they're doing in Firefox Nightly, is the client that's leading the way here. There are Android apps. CloudFlare has a desktop proxy you can use. The next release of Stubby will contain it, and there's a smattering of other experimental implementations client-side. And on the server side, a couple of the open source projects look like they're going to get DoH support soon. And again, loads of people are just spitting out experimental implementations. You can find some more information under the links, but it's changing very quickly. What I want to do, though, is focus on the relationship which exists between Mozilla's Firefox and CloudFlare in terms of what they've been doing experimentally. And this relationship in some places is being called the Mozillas sort of bromance, if you like. So what have they actually been getting up to? So we know that, for example, Chrome has actually always had its own, or for a good while now, has had its own DNS implementation inside Chrome because it chose to do that. There are actually also a couple of browsers out there that have been using encrypted DNS for a while. Yandex uses DNS-encrypt and Tenta uses DoH. But what's been very interesting is that Firefox was a very early implementer of DoH, and it's in Firefox 62 today. So if you're using Firefox, it's already there. It currently isn't enabled by default today. But the interesting question is, where is it going? They have been doing a number of experiments in Firefox Nightly, and I'll talk about this next, but at the moment, they've only implemented using dedicated connections. They haven't started going down this mixed mode scenario yet, but that is coming in the future as well. Now, while Firefox have been the people talking about this, tweeting and blogging about it, I will just mention that as I go through the rest of the slides, be aware that Chrome has also got a DoH implementation inside it. It's not exposed through configuration, and it's not really being advertised, but a fork of Chrome called Bromite has actually exposed it and proved that it works perfectly well. And let's not forget, Google have a handy DNS resolution service that they could probably enable DoH on pretty sharpish if they chose to. And just to mention that one of the reasons we're seeing such a rapid development in the browser world is that, of course, they control the clients, and they can do updates at whatever speed they want, and that's quite different to what's going on in terms of getting OS support. Okay, so why are browser vendors arguing that they should be doing encryption directly from the browser? Well, some of the things that they say are, the OSs have been really slow. Look how slow they were with DNSSEC. They've been slow with DoH, they're never going to do DoH. So we are going to move in, and as a selling point, we are going to protect the privacy of our users and take care of this ourselves, rather than waiting on third parties. Also, a sort of holy grail for browser vendors is they think they can reduce latency and improve the customer experience in the browser if they're doing DNS directly. So why did they choose to go to the effort of getting an extra specification for DoH instead of just using DoH? Well, if you grab the slides, that's a link to a blog by Patrick McManus, who was one of the lead developers at Mozilla. And he wrote a blog calling out a number of reasons that they did it. Three I'll mention here are, to the browser folks, there's an obvious advantage to just leveraging the existing HTTP ecosystem. They want to be able to use DNS in the context of caching and proxying and all the other bells and whistles that they already do for content delivery. Of course, there's a voice coming through saying, why did you bother with a separate port? Just put it on 443, it never gets blocked, it just works. That's the way to do new stuff. And finally, what you can think about is that once you're doing DNS within HTTP, it actually opens up a whole range of other possibilities with the protocol. Now, at the moment, DoH uses wire format DNS, but there's already a specification for how to represent DNS in JSON, and I can't imagine it's a long time before a new media type is defined for DoH that does JSON. HTTP supports server push, and you can imagine a lot of scenarios where a DNS resolver being able to push records out before they're asked for is attractive in a browser scenario. There's also been proposals about something which is called resolverless DNS, and nobody's really quite sure what this is, but there's an argument to say that the thing at the far end of a DoH connection doesn't need to be a caching, validating, recursive resolver as we think of it in the classical DNS sense. It could be something else. It could do all sorts of customization of the queries it sends back if they're within a specific context. So this opens up a lot of possibilities. And in some quarters, folks are kind of going, ooh, that sounds a lot like doing DNS 2.0 without actually doing DNS 2.0. So who knows where this will go. So what have Firefox specifically been doing? So they announced in a blog in May of this year that they were going to do an experiment and that they had some future plans. And a couple of statements they made here really caught people's attention. The first one is that they would like to turn DoH on by default for their users. This is something that they've stated in that blog as a goal. The other interesting thing they did is they coined an entirely new phrase, which is a trusted recursive resolver. And they've said that CloudFlare is their TRR. And what they mean by that is that they've come to an agreement with CloudFlare that CloudFlare have defined a privacy policy that they believe protects their users' data in terms of anonymizing it and discarding it quickly. And actually, you look at it, it's not bad compared to a lot of what you get from DNS resolvers. But they then went further and they said, because we have this relationship with CloudFlare, it means that Firefox can ignore the network provider resolver and send the queries straight to CloudFlare. And that's exactly what they did in their experiment. So they started the experiment in June, and what they did is they took half of their Firefox nightly users and automatically opted them in. And for every DNS query that went to the system resolver, they sent a parallel query directly to Cloudflare, and then they compared the results and tried to evaluate the performance. They published the results just last month, and the thing that caught my eye in the blog where they published the results is that they said the single biggest question that this experiment was intended to answer was, does the use of a cloud DNS service perform well enough to replace traditional DNS? So they weren't looking at itty-bitty protocol details here. They weren't even attempting to compare DoH with DOT. They were just trying to prove this point. Two other things they stated in the blog. One is that from a performance perspective, they saw a 6 millisecond overhead compared to using traditional DNS. And they've said that they think that's acceptable given the cost of encrypting the queries. And in their moving forward statement at the end of the blog, they said, we are committed to building a larger ecosystem of trusted providers, which again speaks to the fact that they think not using a local resolver is the right thing to do. Following that, I had a Twitter exchange with Patrick McManus, who, interestingly, from that first blog, a lot of people read it as, we're going to turn it on as soon as we can, and we're going to turn it on just using Cloudflare. But actually, since then, Firefox and Mozilla have come back and said, yeah, we haven't decided what we're going to do, and we don't know when we're going to do it. We're still working on it. Interestingly, Patrick, who was one of the authors on the DoH draft, actually left Mozilla on Friday, and he was one of the driving forces behind this. So it'll be interesting to see if the same momentum keeps up. Now, he's not there. They've also been going to some lengths to try and make the configuration more user visible. It was really, really buried. You had to go into an about.config tab and know it was called TRR and all of this. So they seem to be hearing that some users are uncomfortable with the idea of how opaque this could have been. But to take the step back and think about what they're proposing here, what is the impact of TRRs becoming a really common model for applications? Well, the thing is that using a TRR fundamentally changes the trust model that exists in DNS today, and that's an implicit consent model, which is by default, you log onto a network, you get a DNS resolver from DHCP, and that's what you use for better or for worse. But this is now taking us down a road where you install an app, and somewhere in the 13 pages of T&Cs it says, by the way, we'll send your DNS queries wherever we think they should go. So this could get interesting. One of the other things to think here is that, is this talking about leading to a potential centralization of DNS services? And it seems very odd that this kind of proposal is coming out from an organisation like Mozilla, who have one of their core principles that they don't believe in centralization of any aspects of the internet. So some people are quite dumbfounded by this move. So reactions are mixed, as you can imagine. There are some people who are saying, well, okay, at least this is provoking the discussion of encrypting DNS, and it's forcing operators to recognize that this is something that is coming and is going to happen. There's quite a lot of people who are just sat going, you know what, I don't know where this is going, and it seems really odd that browsers are getting into this space. And then there's also a whole ton of people who think this is literally the worst idea they have ever heard, and it's the end of the DNS Republic as we know it. So to dig a little more into the specific reactions that we've seen, there are some people who are saying, look, my network, my rules, I want to see all my DNS. It's how I control what happens in my network, and I will do whatever it takes to ban, block, or intercept this kind of DoH traffic. So, there's an argument that operators say they need visibility into their networks, and in some ways there's a few echoes of the TLS 1.3 debate here. There's quite an epic thread on DNS-op that went back and forth on this, so if you have the stamina, you can always read through that and see some of these back and forths. There's also a slight question of, hang on, is this even legal if these applications suddenly start doing this without having got the user consent and opt-in process right? Is this just going to be a little, you've upgraded, click here to carry on thing, and users will be oblivious to this, and network operators could potentially be oblivious until you suddenly see changes in the DNS traffic. There's also a lot of arguments to say, hang on, we need to take a step back and think about the threat models here. Potentially, TRRs could be a useful thing if you're on an untrusted network. If you're in your coffee shop, you might decide CloudFlare is better than random DNS server you get from DHCP there. But then you have to question who gets to decide what's a trusted and an untrusted network. For example, if you just think about your ISP at home, in the EU, we're pretty well covered now by GDPR, restricting what ISPs can do with your data. In the US, with the lack of net neutrality, not so much. Some users see their ISP as the threat on the network. So we at least here need to recognize that users might need some choice. There's also a little voice in the back of your mind going, hang on, the app gets to decide the TRR. What if governments in certain countries suddenly start mandating what the TRR should be for apps that can get through some certification process? What if some TRR operators start throwing money at app developers saying, could you just make us your TRR and then we'll get all your queries and everything will be good? So there's a whole new world potentially here in this model. I would encourage you to read a blog article by Bert Hubert from Power DNS, where he actually also enumerates a number of other concerns here. Two I'll call out are, let's think about this. What can we think about the neutrality of the people offering these services? So CloudFlare, for example, are a CDN. Can you be 100% sure that they will offer the same level of service to DNS queries for stuff hosted on, say, Akamai? Who knows? You could get a conflict of interest here between your resolver and a content provider. And the other question is, how do either operators or users get clear visibility into precisely what legislation will govern who could intercept the traffic going to a third-party provider, or what rules will govern what sites get blocked through that? So we have a lot of questions here that really need a lot more exploring. One other point to make, if you're somebody who manages an enterprise and you have corporate images that you take care of, is to think about the impact on that end device. Now, we've seen some relatively clear statements from Firefox that they want to do this by default. It seems highly unlikely that the other browsers, including Chrome, won't follow or won't do something similar. Then you have to start thinking about, well, app developers are going to go, well, the browsers do it, why shouldn't we do it? So suddenly you have an end device with a really fragmented DNS management structure. It's no longer the default that the system resolvers from DHCP get used. You have multiple configuration points, and in fact, it's almost as if DNS is no longer part of the device infrastructure. It moves much more into the world of content delivery. So this could cause all sorts of headaches, just in terms of managing for users and for corporations. So, what to do? If you're a network operator, I would say, consider running a DOT server in your network. And the reason is that there are already system resolvers that are probing the network resolvers on port 853 and would like to do encrypted traffic. And so in terms of providing service for them, that's the right thing. Start looking at doing DOT within your network. Another thing is to brace yourself for the need to potentially run a DoH server on your network in future. Now, today there is no discovery mechanism, but as a minimum, it gets you in a position to be running a server. It gives your users choice. You can advertise that you have your own server, and not acquiescing to the idea that applications should just use their own TRRs and potentially go to centralization of DNS service in the hands of a few big providers is a good thing. Also, watch this space. Things are changing really, really quickly. There is a proposed draft on how to do a sort of insecure, opportunistic discovery of a DoH server on the local network. It's like 2 weeks old, though, so I think it needs a lot of review. There's been proposals for discovery over DHCP, although there's been a lot of pushback in the IETF because DHCP isn't seen as secure. But the reality is that's what the vast majority of networks use to discover your server, so there could be something that comes out of that. So I think being aware of the discovery side of this is useful. If you do decide to enable either DOT or DoH on a local resolver, I would also encourage you to think about the fact that the focus is now on resolver operators and how they manage data. There is a separate draft, which is a best current practices for people who run services that encrypt the transport, because the focus then goes much more onto what are you doing with your users' data? Are you anonymizing it? Are you sharing it? How much are you publicizing about what you do with your users' data? Because it could be in the near future that users will start actively choosing services on the basis of privacy policies, and they'll choose the ones that offer what they think are the best practices and policies to do with handling their data and maintaining privacy. I would also say keep an eye on the website at dnsprivacy.org. We also have a Twitter feed, and we try and tweet there if we hear things. You know, if the protocols evolve, we get new servers. If we hear about configuration changes in Firefox, we'll put it on that Twitter feed. So basically, stay tuned in this area. I think the next 6 to 12 months will be when we really see, or we really start to get clarity from the browser vendors as to what their intentions really are in the space, because at the moment, we've got some mixed messages, I think, it's fair to say. So that's everything I have on my original topic. I was, hopefully if the timekeepers are okay this, I have one extra slide that I was going to scoot in here. So I'll go ahead and do this and then take questions, if that's okay? Yeah, okay. So while I'm here, I was asked just to mention again to this audience as a heads up in a different space, something else which is happening really in the recursive to authoritative world. So what I wanted to make you aware of is a collaborative effort between, they're called the Big Four open source DNS implementers. So that's ISC, who make Bind, NLNet Labs, who make Unbound, PowerDNS, and CZNIC, who make NotResolver. And what they've done is they've got together to have a coordinated effort to try and address some of the problems that they have as Resolve implementers due to a lack of compliance in how eDNS 0 is handled in various networks. So today, those recursive implementations all have a variety of workarounds that they use to handle the case where they send a query out which has an eDNS 0 option in it and something goes wrong. Very commonly, they get a complete timeout from the far end. Sometimes they'll get incorrect responses. They'll get an NX domain or a serve fail when they really shouldn't. And they see a whole variety of cases. And what they've had to do is implement workarounds to cater for that fact. The worst one being a timeout because it just slows everything down. What they've decided to do is draw a line in the sand and say that as of February the 1st next year, they intend that their releases, that the most recent releases of their software by then will have removed all those workarounds and will do a far more efficient fallback to each of the servers it can go to if it doesn't get eDNS answers from the first one. What this means is that the very small percentage of cases where the network or the zone being served is not compliant, the onus will be on the operators to fix their non-compliance, and this will hugely simplify the software for the resolvers and the efficiency of the resolver process. So, is this a problem for you? Well, only if you run an authoritative zone and you're not compliant. And if you want to know, go to that website. You can put your zone in there, and it will tell you whether or not you're compliant, and it will give you some hints as to how to fix it and what's wrong. And so this is a first stop place to figure out what's going on. So I encourage you to go there. There are some various other tools to check your zone, DNS Viz, all sorts of things like that. But be aware, this is the first of one of the coordinated efforts to try and increase compliance in networks and reduce complexity at resolver implementations. Okay, and with that, I think I am done. Thank you. So I'll take questions if there are any. Jim in the back.
Hi, Sara. Greg Jules from 3. Thanks very much for that excellent presentation. Performance, Mozilla have said an extra 6 milliseconds, which concerns us as a mobile operator because there's an awful lot of delay already built into the RAN, and an extra 6 milliseconds is really going to slug these things. The other thing was DNS at the moment is kind of predicated on caching an awful lot of stuff, and these things are very, very hungry in terms of DNS. How do they see it scaling at all? Because there must be billions of queries a second globally. How are they just going to handle it at all? So
are you asking about the resolver side there, or the device side, or
just about, you know, if all of these things start to implement their own, you know, streams over HTTPS or however it's done, I don't see the volume of queries from an end user device decreasing any, but they're all going to end up in certain central places, which is kind of destroys the decentralized nature of DNS as it is today.
Yes, so there's various things. One is that they're going to probably have quite aggressive caching on the device. They're using persistent connections to try and reduce the number. And I think they see this moving towards mixed mode, where you're just doing extra queries within existing HTTP connections. And the argument is, one of the reasons they're talking to people like CloudFlare is because CloudFlare are basically saying, we're a CDN, we know how to handle high volume traffic, we know how to handle DOS attacks on HTTP. We've got this. So whether that's true or not, time will tell.
Hi, I am DNS Jim. Sara, great talk. A couple of quick clarifications or things you just sort of kind of think maybe I've skipped over a little bit. Yeah. And then also must take issue with something Greg just said there. First of all is that looks as if there's going to be an IETF working group being spun up to look into this issue of resolver identification. So there's the DRUI. They had a BOF session in Montreal last IETF, and I think that may turn into a working group. And one of the ideas that was suggested during that BOF session that Patrick McManus mentioned was that they could maybe have a mechanism similar to how web browsers handle root CS, where there's a whole bunch of these trusted resolver configurations plugged into the browsers, and then the end users get the choice of selecting between them or having them all potentially switched on. Now, Patrick was just shooting from the hip, but it was just, that's a suggestion as perhaps one possible solution for that problem.
So my understanding is that DRU, or however you pronounce it, isn't going to be a working group, it's just going to be a mailing list for the foreseeable. But that could change. But that's, and the same is true for the resolverless DNS discussion. Yeah. And those mailing lists have actually been suspiciously quiet since the last IETF.
Yes, I've noticed that too.
So I think that's interesting. Yeah. And I think, yes, we should fully expect browsers to start pinning CA certs in order to bootstrap the authentication.
Okay. The second point, which actually two things. One is to pick up on what Greg was saying, but also something I think you missed on, Sara, in this whole scenario, is that, to my mind, the way I think this is going to work is not going to be so much with the web browsers making queries over DoH. I think it's more going to be the web servers pushing stuff to the browsers over DoH. So, for example, the web browser might do a lookup, say, to Facebook, so that DNS lookup will go over DoH. But all the crap that Facebook then sends back with all the banner ads and everything else you're going to get, they'll be shoved back over that DoH channel so that the web browser doesn't have to resolve those individual URLs to load those particular page elements. So that will probably mean that there'll be less potential, fewer DNS queries, potentially. And also the latency issues might also be engineered, but yes, there'll be the overhead of the crypto, but the fact you're getting so much more DNS data coming back over that secure channel could potentially mean that there'll be less latency and there'll be fewer DNS lookups being made. And also in relation to that is potentially in the context of DNSSEC, potentially the content provider, whether that's a Facebook or whether it's a CloudFlare or whatever, could be shoving back all of the DNSSEC records that you need, from root certificate to all the signatures, all the delegation chain could be pushed back in one single HTTPS operation. And that will then also potentially speed up the latency considerations.
So, yeah, I brushed over it just by briefly mentioning server push, which is part of the current DoH specification, so that covers it. So, yeah, I think that's certainly an area where browser vendors see them being able to take advantage. I mean, there have been numerous proposals to do that directly within DNS, and none of them have really got anywhere. They've stumbled a bit, and I think the path will be way easier for browser vendors to just implement that and get on and have it done. But
I think the thing is, what the Acubis and the CloudFlares and the Facebooks and these other large providers going to be doing with DoH and actually shoving data out to the browsers, I think that's a much more likely, more credible model than having the end-user device making these lookups. Yes, that will certainly happen, of course, but I don't think it's going to be the major use case, in my own personal opinion.
And I also think some of those answers that come back will be customised.
Exactly.
For not just geolocation, but context customised. And I love your optimism that the fact that browsers will ever do DNSSEC down to the client. We can hope.
We live in hope.
Indeed.
Okay. Next question, yeah.
I'm probably going to be slightly controversial here, but I'm representing my customers. The number two thing that people look at when they buy broadband is parental controls. And I know some of us where our kind of information should be free flags are probably burning them as I speak. But frankly, being a granddad, believe it or not, and my 6-year-old granddaughter being a genius on the iPad, it's something that actually I've paid a lot more attention to now. I think some of these companies are in danger of really bringing in a layer of regulation that would be bad for all of us. So if you think about it, many of us lived through the Internet Watch Foundation and the kind of pseudo-regulation that was. This is an area where the government, at least here in the UK, will definitely aggressively act, in my view. And I think in the EU, there might be some action there as well. So I think, I don't know, some of these companies, Mozilla and CloudFlare, seem to live in a black hole somewhere where they can kind of, they think they know what's right for us. But I think, they really need to think about how local organisations may affect this. And then also, even more on top of this, it could actually have an even worse situation where, and we've seen this in some countries where the government controls DNS. And this makes this really easy. I mean, for me, DNS was a hierarchical thing that was really difficult to capture. And I don't know how many Nanog presentations I saw where this evil Korean guy grabbed DNS and they were evil, yet this looks like they're doing it in front and centre of us and that's okay. That just feels nuts to me.
I mean, Mozilla have gone to lengths to say we regularly see our users getting attacked through the DNS and this is our mitigation for that. Yeah. Whether you buy that or not, and whether you think what they're doing is right or not, they feel like that's their justification. But again, you're quite right. There are lots of countries where there are regulations where ISPs are required to block certain sites, and this will bypass that. I mean,
in one area, we've got a whole bunch of High Court actions that this would get in the way of. Again, some people might be jumping for joy for that because but the law is what the law is. So, and the second part I just wanted to add to that was an extension of what Greg says. If you look at all of the kind of performance stats that the regulator in this country gives, DNS is one of the major contributors to it, and the regulator, perhaps not intentionally, but certainly in spirit, wants us to provide a good service on this space. There's no question about that, and actually, in doing so, have improved the quality of DNS in this country massively compared to where it was. Again, this just takes that out of our hands, and it, I even in the idea of us just being the dumb pipe provider, I always
Neil,
thought that
can you
included
wrap it
DNS.
up? It's coffee time.
Basically, sorry. Anyway.
But if I can answer
it's
with,
nuts.
with
is my,
one other thing, one comment that was made is this is the browser vendors playing chicken with the operators and potentially governments, and I think, yeah, that's fair.
Okay, thank you, Sarah.